Now we're going to take each of these three branches of the ANS, the sympathetic nervous system, the parasympathetic nervous system, and the enteric system, and discuss them individually. We'll start with the SNS, the fight or flight response. The SNS, or fight or flight response, involves multiple overlapping branches of the neuroendocrine system. The sympathetic nervous system overlaps with a system called the hypothalamic pituitary adrenal axis, also known as the HPA axis. Another axis, which we've already talked about in an earlier lesson on the menstrual cycle, is the hypothalamic pituitary gonadal axis. That's the HPG axis. And the third system involved in the fight or flight response is the immune system. So I know there are a lot of big words here, and it's probably activating your own SNS, but not to worry, I'll explain them. This slide explains the hypothalamic pituitary adrenal axis. This is the main pathway of SNS activation. Now, the name itself tells you exactly what structures are involved. First, the hypothalamic in the name refers to a region of the brain called the hypothalamus and also includes the brainstem. These areas of the brain produce a group of hormones called endorphins and cortisol-releasing hormone, also known as CRH. These hormones tell the pituitary gland, the P in HPA, that a threat is upon us. So the pituitary hears this message and says, oh no, there's a threat, and then passes on this message of the threat by way of ACTH, vasopressin, and growth hormone to the adrenal glands. The adrenal glands hear this message from the pituitary and say, game on, let's deal with the threat, and they secrete cortisol, testosterone, epinephrine, norepinephrine, aldosterone, and it's these hormones that increase heart rate, reduce pain perception, increase respiration, and turn off digestion to make the body ready to fight off the threat. So we see a similar theme here to what we saw with the menstrual cycle. The menstrual cycle, as we reviewed previously, is a hormonal conversation. So is the stress response. And as you can see here, the hormones, the long list that we mentioned in the slide, are the language by which the brain, the pituitary, and the adrenal glands talk to one another to stave off a looming threat. Now here's another pathway. You've seen it before. The HPG, or hypothalamic pituitary gonadal axis. This is the pathway that involves reproduction and, in women, the menstrual cycle. Now, two of the players are the same as in the HPA. That's the hypothalamus and brainstem and the pituitary gland. But they produce different hormones in this pathway. Instead of the adrenal glands being the endpoint, we instead have the ovary, or in men, the testicles, as the endpoint of the message. And the G refers to gonads, and that refers to ovaries and testicles. So let's look at the HPG axis in more detail. The messaging of the HPG axis, which in females governs the menstrual cycle, begins in the hypothalamus and brainstem with the release of endorphins and GnRH, which is gonadotropic releasing hormone. GnRH stimulates the pituitary gland to release follicle-stimulating hormone, or FSH, and luteinizing hormone when an egg is ready to be ovulated. The ovary hears this message from the pituitary gland and produces estrogen and testosterone in response to FSH and LH. During ovulation, when you see the surge of LH, as you might remember in the previous lectures, testosterone is produced in response to that LH surge, and in women, testosterone increases sexual behavior. So this makes sense. If there is an egg being ovulated, it would make sense if pregnancy were to happen that sexual behavior would need to increase. Now, the HPG axis is always functioning. This is what is functioning month after month to give females a monthly menstrual cycle. So think of it as always being on. Now, the reason I raise this as part of the stress response is because when the SNS is activated, the HPG conversation gets turned off. So the point here is that when the HPG conversation is happening in times of tranquility and low stress, the SNS is then activated in times of a threat and then turns off the HPG. And this makes sense, right? Because if a bear is in the woods ready to eat you, it's not a good time to be procreating. So the body turns all of its attention to fighting the threat, and the SNS makes sure that the body's forces are armed and ready to deal with the threat. And that sometimes means other things need to be turned off, like the sexual response as well as digestion. Now, the one single point to take away from this slide is in the red circle. So on the left and on the right, these are the two axes we were just reviewing on the other two slides. There's nothing new here. But what I want you to focus your attention on is in the center of the slide, what's in that red circle. And that is when the SNS is activated on the left, when the threat is looming, when the fight or flight response is in full throttle, this is turning off the HPG. So this is a very important relationship to understand. This is why many times elite athletes who are overtraining and undereating, the body perceives a threat. And this is why they lose their periods many times, is because the body is looking at the overtraining and undereating as a stress. And when that stress response is activated, one can lose their periods.